Hi, so now I'm gonna talk about how to set up the simulation. So here you can see the grid has these parameters: rows, columns, number of preys, and number of predators. So the rows and columns can be predetermined by you, the user. For example, I'm using 5 times 5 here. And then the number of preys and number of predators will be their positions will be randomly generated by a random number generator that I'm using. So for example, I want to randomly generate a position for a prey. I just need to generate two random numbers. For example, I'm using 5 times 5, so it would be a number between 1 to 5. For example, I have two randomly generated numbers, 3 and 4. Then it will be on row 3 and column 4. And then here you can see the parameters for the preys are the reproduction countdown and the scent decay. So for the reproduction countdown is after they reproduced, there will be a countdown for them to not be able to reproduce again for the predetermined amount of turns. And then the scent decay would be how long would the scent be on the grid, and then it will disappear. For the predators, there's a lot of parameters. First of all, their initial energy, so the energy that they're spawned with, and the move energy, so how much energy it takes for them to move one unit to the adjacent unit. And then the reproduction energy is how much energy it's gonna cost them to reproduce. And then the eat energy is how much energy they'll gain from eating a prey. And then the search radius would be the radius that they will not be dormant and start chasing after the prey. And then you can see here for my demonstration, I use the grid as rows equals to 5, columns equals to 5, and then 3 preys and 2 predators. And then for the preys, the reproduction countdown will be 2, and the scent decay will be 3. And then for the predators, the initial energy is 5, and then the move energy is 1. The reproduction energy is 5, and then the eat energy is 3. And then the detection radius will be 1. So here I randomly generated their positions using the random number generator. And then you can see there are 3 predators and 3 preys and 2 predators on the grid right now for step 1. And then the small numbers on the upper right corner for the preys, it represents the reproduction countdown, and for the predators, that represents their energy. You can see that for all the random movements here, I use a random number generator, and you can see I marked, so there are 6 possible next positions for a prey. So I use the random number generator generate a number from 1 to 6, and then it will determine their next step. So here, the prey, first of all, the prey on the second row and the third row reproduced and produced a new prey on the third row there, P0. And then the 2 parent preys, they move to a new position based on the random number that the random number generated. And then the predator here, it ate the right prey on the third row, and then it gained 3 energy points, and then it also decreased 1 point by moving to the other cell here. And then you can see the 2 parent preys, they also have a 2 on the upper right corner there. That represents the reproduction countdown is now 2. And then the predator on the 5th row didn't move because it's dormant. The radius is set to 1, and there's no prey that's within the radius. And then moving on to step 3 here, you can see that the predator X7 ate another prey, so now it's at energy level 9. And then the updated prey locations and the updated scent data. And also on step 4 here, it shows that preys and predators can move on to scent cells. That doesn't block them. In step 5 here, you can see P0 on row 5 will probably be eaten on the next step. And then, yeah, for this simulation, it feels like all the preys are going to be eaten.